Hello students, welcome to lecture 1 of unit 3, Electrical and Magnetic Properties of Atoms and Molecules. In this discussion, we will talk about the electrostatic force, electrostatic potential, electrostatics of dielectrics, and polarizability. So what are the main features of electrostatic force? There are existence of two types of charges, positive charge and negative charge. And like charges repel each other and unlike charges attract each other. There is also a decrease in the electrostatic force with respect to distance. Now, as we can see here, this is how the electric field lines appear for two unlike charges, that is one positive charge and one negative charge, and there is attraction of oppositely charged objects. For like charges, there is repulsion, as you can see in the electric field lines. These are two negative charges and these are two positive charges. Please note the difference in the direction of electric field lines in both these cases. Here in the image are shown the most common example of electrostatic, that is the attraction of small pieces of paper by a comb, and also the natural phenomena lightning. So what is electrostatic force? It is an attractive or repulsive force between particles, and it is caused due to the electric charges that are present. It can also be developed in a stationary charged body. Electrostatic force is also known as Coulomb's force, to pay respect to the French physicist Charles Augustin de Coulomb, who actually determined this electrostatic force. And why is electrostatic force important in chemistry? Because this electrostatic force helps to solve the forces which are generated by the configuration of charge. As you can see, for charge Q1 and Q2, which are separated by a distance r, the electrostatic force is given by this particular formula, where F, electrostatic force, is equal to K, which is a constant, into Q1, Q2, and this whole term is divided by R square. Here we also note how the like charges, two negative charges and two unlike charges, this positive and negative charge, attract and repel each other. So now let us discuss what is the nature of electrostatic force. Electrostatic force is generated by static charges, that is the charges that are not moving. Electrostatic force field is conservative. Now what are conservative fields? The force is conservative if the work it does on an object moving from point say A to another point say B is always the same. Okay, so if the work it does on moving an object from this particular point to this particular point is same, no matter what path is taken, then the force is said to be conservative. That means the integral of that area is always path independent. Now electrostatic forces between like charges is repulsive and between unlike charges is attractive. Okay, and electrostatic force between point-like stationary charges also follow the Coulomb's law, where Coulomb's law says that the force of attraction or repulsion is given by F equal to K Q1 Q2 by R square. Now let us talk about the electrostatic potential. What is electrostatic potential? It is the potential energy which is created by the electrostatic interaction between the charged particles. So the electrostatic potential PE, or potential energy, is directly proportional to Q1 Q2 by R. Where the force was inversely proportional to R square, potential is inversely proportional to R. Okay, so the nature of an atom, chemical bonding and intermolecular forces. So understanding all these things depends on the influence of charge-charge interaction that contribute to the energy of the system. As can be seen in the graph, for opposing signs, that is for unlike charges, the potential energy will be always negative. Okay, it will always be negative, and as the separation approaches zero, the potential energy becomes infinitely negative. However, for two like charges, say plus plus or minus minus, for charges of the same sign, the energy of repulsion is always positive and becomes infinitely positive as this R value becomes 0. Here I have also mentioned some important units which are used for determining the electrostatic potential. Now let us discuss about the dielectric constant and electric field. What is a dielectric constant? For a medium, it can be defined as the ratio of force between two charges. For two charges that are separated by some distance in free space, to the force between the same two charges separated by the same distance in a particular medium. So it is a ratio. Here, as you can see, it is a ratio of this F1 by F2. Okay, now what is electric field? The strength of electric field is measured by the force experienced by a unit positive charge at that particular point, which is given by this formula. Now let us discuss about the electrostatics of dielectrics. We already know about conductors and insulators. Conductors are those substances that are able to conduct electricity. For example, metals. In metals, charges are free to move throughout the material. However, for dielectrics, all the charges are attached to specific atoms and molecules and form bound charges. These charges are able to be displaced within an atom or molecule. But with the presence of an external electric field, it becomes polarized and acquires a dipole moment. This property of dielectrics is known as polarizability. That is, able to acquire a dipole moment is known as polarizability. Now, in chemistry, the molecules have both positive charges in the nuclei and negative charges in the form of electrons. When an electric field acts on positive charges, they are displaced along the positive field, whereas the negative charges are displaced in the direction opposite to that of the electric field. So the effect pulls the opposite charges apart, that is, it polarizes the molecule. Okay, so the polarizability is written in terms of alpha of an atom, and for a given local electric field, this is the formula that we use, where alpha for a non-spherical atom is equal to the tensor. Let us look at the example of two very common molecules, water molecule and carbon dioxide molecule. For the water molecule, the dipole moment of the two OH bond, as you can see here and here, add vectorially to give a vanishing net dipole moment. And the dipole moment for two CO bonds here and here results in a net zero dipole moment in absence of an electric field, because they cancel each other out. Therefore, individual molecules in a dipolar substance having a permanent moment, the net polarization may vanish in absence of an external field, because the molecular moments are randomly oriented. They are not oriented in a particular direction. So, since they are oriented randomly, it can result in a complete cancellation of polarization. When a field is applied to a substance, the molecular dipoles tend to align with the field. Okay. What is polarizability? So, when an electric field is applied to a medium, the charges bound to each molecule will respond to that applied field. This results in redistribution of charges, leading to polarization of that medium. The electric polarization is defined as dipole moment per unit volume. Please remember the definition of electric polarization. It is the dipole moment per unit volume. For a macroscopic quantity, it becomes a macroscopic quantity because it involves averaging of dipole moments over a volume that contains several dipoles. Okay, with this we conclude today's lecture. If you have any doubts, please do not forget to email me or WhatsApp me. I shall be available there. For today's lecture, thank you for your attention.